Okay, so in this installment of 6-3 Simplifying Radical Expressions, we are going to be using that product rule for radicals to actually multiply radicals here. Now, it is very important to note that this product rule for radicals, when seen as a rule to multiply radicals, the index of those radicals must be the same. So we've got to be multiplying. If I want to use this rule to take um, and write it underneath one radical symbol, we do have to have the same index here. So in order to do this, square root times a square root, cube root times a cube root, a fourth root times a fourth root. Otherwise, we would have to be doing some different things um, if it was even possible to multiply those two radicals. So here we've got the square root of 20 times the square root of 80, or sorry, times the square root of 8. So we are going to say that that equals, so both of these are square roots. So I can recombine that product underneath that radical symbol. So the square root of 20 times the square root of 8 becomes the square root of 20 times 8. And that becomes the square root of 160. Now at this point, I'm not going to go back over how to simplify by factoring. Um, if you need help with that, go revisit the first video or reach out to me. I will also point out that this calculator, when in the appropriate mode, which is the math print mode, will simplify radicals for you, which is pretty amazing. So it tells us that the square root of 160 is 4 square roots of 10. And to keep this video on track, I'm going to go ahead and let you in on that little calculator support if you didn't already know about it. Okay. All right, now let's move down to B, which is the square root of 3x cubed times the square root of 6x fifth. Again, we are multiplying a square root by a square root, so we can combine that product underneath one square root symbol. So that's going to be the square root of 3x cubed times 6x to the fifth. So we're going to have to use a couple of things in conjunction here. So we've got the square root. Okay, so you got to remember when you are multiplying monomials like this, we multiply the coefficients. So 3 times 6 is 18. And be very careful here that we add those exponents because that's the same base. So we are allowed to add those exponents there. So just be very careful that you're adding those exponents and not multiplying the exponents in that instance, because that's not x cubed to the fifth power, that is x cubed times x to the fifth. Okay, so we've multiplied now. Now we need to simplify. So now we're going to go back up and say, okay, so now I have this is the square root of 18 times x to the 8th. So I'm going to use my product rule in reverse to help me. Square root of 18 times the square root of x to the 8th. At this point, if you didn't want to use this rule in reverse, you could go back to what we were doing in the 6-2 videos, and you could actually write that as 18x to the 8th to the 1/2 power, and then you can apply your exponent rules to simplify. So there are several different ways to simplify radical expressions. This is simply kind of taking just a little bit of a different track. So hopefully we remember that the square root of 18 is going to be 3 square roots of 2. And again, if you got this handy dandy calculator, you can definitely allow that calculator to support you with that. So 3 square roots of 2. And then times, so this is going to be x to the 8th to the 1/2 power. And so my final answer there, once I get this, so 3 square roots of 2 times, that's going to be an x to the 4th because that's a power raised to a power, so I get to multiply 8 times 1/2, so that's going to be 4. Typically, just with how we generally like to express our final answers with radicals, the radical symbol typically comes last in our product, so we're going to rearrange this product because this is 3 times the square root of 2, so multiplication can occur in any order. So I'm just going to kind of stick that x to the 4th in between the 3 and the square root of 2 notation. And again, that's just kind of traditionally how we express final radical notation form, is that radical usually is expressed at the end of the product. All right, and that is the end of this video.